Hello all and welcome back to your daily news. As usual, someone in the government is arguing. Breaking news! A huge, gigantic, ginormous attack has just been laid inside the Pentagon. Is it a grenade? Is it a big bomb? This just in. The attack has been identified as a huge, gigantic, ginormous fart. The Declaration of Independence under attack. Government officials have locked the doors inside one room to trap the fart. But who knows what will happen if this too continues to spread. We turn to our hero fart detectives, Rainbow Explosion, in this time of need. Will they fix this gassy problem?
Greetings, concerned Gaslandia citizens. Don't fear, Rainbow Explosion is here.
Rainbow Explosion!
Here we have a rather large fart. This fart is a gas. A gas is a gaseous or vaporous state of matter made of tiny particles that move rapidly and randomly far apart. It is also a substance that has no fixed size or shape and fills whatever container it is in. The kinetic molecular theory makes 5 assumptions about how ideal gases behave. I hope this fart is an ideal gas. I mentioned the first one earlier. Number 2 talks about collisions. When gas particles collide with other particles, they are called elastic collisions, which means no energy is lost. This means the fart is not losing any energy as it lifts the Pentagon. Number 3 discusses the movement of said particles. They are always in motion. Number 4, there are no forces of attraction between the particles, meaning this fart has been expanding with no stop. Finally, number 5, the average kinetic energy of gas particles depends on the temperature of the gas. Since this fart is very warm, the kinetic energy has been increasing rapidly, causing the building to be lifted off the ground and into...
Oh, hey, dude. Are we talking about gases? I'm Xander, the second member of Rainbow Explosion. Let me give you a little education lesson on gas properties. I love gases.
Rainbow Explosion!
So, all gases have 7 properties: expansion, fluidity, low density, compressibility, diffusion, and effusion. Expansion is a gas's ability to become larger, like in hot air balloons. Fluidity is a gas's ability to flow through the air. Low density is how gases have a low mass to volume ratio. And compressibility is a gas's ability to be compacted. Diffusion is how gases spread out evenly to fill a space. And lastly, effusion is a gas's ability to fit through small openings.
Also, gases have certain variables that affect the way that they behave, and that can also be used to help you figure out things about them. The variables we use are P, V, N, and T. P equals pressure, which is measured in torr, ATM, kPa, mmHg, and other uncommon units. V is volume, measured in liters. N equals moles, and T is temperature, measured in Kelvin, which can be found by adding whatever the Celsius temperature is by 273. R is the ideal gas constant, measured in 0.08821 atm liters per k mole. It's written all here. Or 8.134, which is the ideal gas constant for kPa, and 62.36, which is the ideal constant for mHg. Now, special interviews with the original scientists who came up with each of the gas laws that can help us find our fart bandit.
Hello. My name is Jacques Charles. I am the creator of Charles' Law. My formula is V1 over T1 equals V2 over T2. My law states temperature and volume increase and decrease together with constant mass of gas. Hello, I am Robert Boyle. Yes, you probably know me from my creation of Boyle's Law. Yes, it is me. My law states that pressure and volume move in opposite directions at constant temperature. It is an indirect relationship. My formula is P1 times V1 equals P2 times V2. Thank you.
Hey, I'm Gay Lusek, but you don't care about my first name, am I right? Anyways, yeah, I'm the creator of Gay Lusek Law. Duh. It wasn't even that big of a deal, just something that popped into my head one day. LOL. My law states that temperature and pressure increase or decrease together with constant mass of gas and volume. It's a direct relationship. My volume is P1 over T1 equals P2 over T2. Bye!
Well, hey there. I'm a medio avocado, but don't call me avocado. It's my #1 pet peeve. Wow, you're so cute. Oh, yeah. My law states that volume increases or decreases with more or less gas particles. Moles at a constant temperature and pressure. It's a direct relationship. V1 over N2 equals V2 over N2 is my formula. But my number is 6.02 times 10 to the 23rd, in case you want to call me. Oh, hi. I'm John Dalton. Nice to meet you. Well, I created the partial gas law, Dalton's law. At constant volume and temperature, total gas is exerted by a mixture of gases, is equal to the sum of pressures of individual gases. Pressure depends on the number of particles, not the type of size of particles. My formula is P total equals P plus P plus P, or however many P's you have. Some other laws that don't happen to have scientist names are combined gas law and ideal gas law. They are both combinations of all gas laws. Combined gas law is P1 times V1 over T1 is equal to P2 times V2 over T2. And ideal gas law is PV equals nRT. That's all from us. Back to you, Rainbow Explosion.
Rainbow Explosion!
Wow, that was quite the group.
I know, scientists, am I right?
Hey, that's homophobic!
Now that we know all that information, we can figure out what law to use to figure out who farted. The root of the compact 59.1 liter fart is filled with 7.1 moles and 99 grams of nitrogen at 19 degrees Celsius. With all of this information, we know that we have the volume, the moles, the constant, and the temperature.
Meaning, we have to use the ideal gas law formula to find the pressure of the fart in ATM and find our farter. So first,
and when you multiply and then divide, you get 2.9 ATM, since that is the only
value left.
Now we know the fart's pressure is 2.9 ATM.
Let's find this evil, despicable person who cut this cheese.
Not literally cut cheese, but the person who farted.
Hello, I'm President of Gaslandia, and we thank you all for your service to the country. We've already solved for the pressure of each of these notorious farters' farts, so we hope you can use your chemist try skills and find the person who has attacked our country so.
Thank you, Mr. President. It's all in a day's work of being fart detectives.
Here we have our 4 suspects. Blue as in Blue Clues fame, Sonic as in the Hedgehog, Wolfie as in Wolf, Easton as in Squishmallow trademark, and Juno the dog. Blue had a rate of 2.2 ATM. Sonic had a rate of 0.9 ATM. Wolfie had 1.8 ATM. Easton with 1.7 ATM. And Juno 2.9 ATM.
That means Juno is the farter!
Put her behind bars, boys.
Sorry, girl. It won't be for long until you're gonna start farting.
Thank you for your work for Gaslandia. We love you, Rainbow Explosion.
You're welcome, Gaslandia. We love farts!
Rainbow Explosion! Bow.